What we are doing it here is that we're making alterations, butyl groups introduced to the benzene. So many people may think that this can be done by the Friedel-Crafts alteration because you see the alkyl groups and the product. So you got the butyl chloride, aluminum chloride, then we expect the butyl carbocation forms. That carbocation is going to be attacked by the benzene. You get the sigma complex, total loss. We can make the products that we want to make. But you know that this is not going to happen. So this is kind of a trap that we lay down. What is going to happen if you do this way? This primary carbocation is not stable, right? There's a problem. So what the carbocation does, it does go through the rearrangement. And then adjacent hydrogen is going to move over there and get a secondary carbocation. Then the secondary carbocation is attacked by the benzene. So you get the sec butyl groups sitting on the benzene. So that would be the main product that you will get if you do these reactions. But we want to make this. So how are we going to do it? So that's the way that you want to remember that trick that we discussed before. You rather want to do the acylation reactions because the acylation reaction doesn't do the rearrangement. So, but you instead of the alkyl chloride, you need the acid chloride. So it's a butyl chloride, a butyric chloride there. Aluminum chloride, and you get the aluminum ion that's attacked by the benzene. So you get this ketone sitting on the benzene, the protons lost, and you get this, acyl product. That's a Friedel-Crafts acylation reaction. We're not there yet, but the only thing that we need to do is reducing the carbonyl to the alkyl groups. Then we can make that up. Then you should remember that there's a two-way we can reduce the carbonyl of this, and then to make that is either Clemmensen reductions or the Wolff-Kishner reductions. But at this point, there might be other methods available to you. Can you reduce that? Can you make this happen without using any of these methods? Can you think of a way to make it happen? That's why you kind of need to open one knowledge there. So let me remind you that this is a ketone, right? If you treat a sodium borohydride, ketone can become an alcohol. What can we do with alcohol? You treat a strong acid, then it will be dehydrated. The water goes away, make the carbocation, even elimination with the double bonds there. Then what can we do to double bonds to make it saturated? With the hydrogenation, adding hydrogen with the metal characters. So these conditions, I know this is a one-step reaction, so that's what we prefer. But if you forgot that, there's a way available. I mean, you're going to start seeing that, can two questions are somewhat open-ended. You can have a variety of different ways to make it happen. And that takes a little bit of creativity. But as long as you go to say destination, things may not matter how you look at it. So then could evolve the right answers. And obviously, some answers may be better than the others. Let's say, for instance, you want to travel to the Los Angeles from here, and you want to take a flight to DFW to the LAX. You don't go to the JFK and then come back there, right? There's a kind of wrong answer. I mean, it's possible, but nobody wants to do that. So, but there's a way. If someone found out that anything is way more cheaper, then I'm pretty sure that you want to take it instead of taking the wrong route. So there's always a trade-off sometimes. So recognizing multiple answers are kind of things that you want to do it to make sure that you're on top of your reactions. I highly suggest that. Anyway, this is a kind of a question that we ask a lot, so I want you to aware of now. This is a question that we probably haven't seen it, but I'll tell you. We ask these questions, and then I get so many wrong answers. So I really like to just answer it rather than just asking this and crossing it out again. This is a question. We got benzene, we got alkyl chain ending up. So if you learn those 5 reactions, then you could easily think about, yeah, that's an alkyl chain. If you get the chlorine versions of that using the aluminum chloride, then it will make a carbocation forms, right? Taking these chlorines out, you get the carbocation, that's attacked by the pi electrons, you get the diazoxide ion, proton goes away, you make a product. There's nothing wrong there, right? All seems to be proper. But you probably see the tones of my saying that this is not happening. It looks reasonable. But there are something reasonable on paper, but things not happening in reality is because of the 2 reasons. This is not stable molecule. You don't get it. If you somehow make this one, what happens is oxygen as lone pair is coming in and kicking the chlorines out almost immediately, and it becomes a ketone. But because of that, these reagents is not what you'll be able to get. Somehow, you are forcing the molecule to stay that way without getting into something else, and you may be able to make the reaction go this way, but things of that task is impossible. Molecule is not listening to you. So that's the reason why this thing doesn't happen. It looks like a Friedel-Crafts inoculation reaction. It's clearly alkyl chain is what you add on there. It's just when you have alcohol there, it's not happening with anything either. The thing is that makes things difficult. So how will you do it? If you have to do this reaction, if you have to make it from that, then how will you do it? Is there another way to do that? That is something that you may ask me to slowly concentrate the same thing. So sometimes it might be easier to walk backward. Let's say this is the one you see here. Then I may say that, yeah, I don't know where we're going to make it, but this is an alcohol, we're going to chain. So if you get the ketone, and then if I'm adding the methyl groups there, then we can make it. What reaction do you think can make it happen? Yep, that's a Grignard reagent. Grignard attacking the carbonyl of the ketones and then making an alcohol. So that means that you only need to make this one. That's a ketone, benzene ketone. And benzene ketone can be made from the Friedel-Crafts acylation reaction. So what you did is this acyl chain. So acetyl chloride with aluminum chloride, put these acyl groups there, then you just have to attack by the Grignard,